Oh, I totally forgot to do something. I didn't properly get ready like a big dum dum.
Bye.
Do, 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 do. Okay, what was I doing? Right. We're gonna finish. Okay, this week or today, I should say. We want to have despawn and respawn, and then we're gonna work on maybe AI or something like that, or driving. Actually, we might work on the driving. I think we're gonna work on the driving. We need we need we need driving. We need to work on the driving a bit more, so we're probably just gonna do that today. Actually, no, I think we need the restart. The despawn for the ragdolls first. Which means that we need a despawning system. We need a way to destroy these these things. I forgot to change my thing, and I don't know if my Twitch is correct. So it's gonna take me like a little bit of time to get back on, get back into these things. You know, being out for so many days, sick is just like not the greatest. Oh, Twitch is back to the correct stuff, so that's all that matters. Okay, so let me close that. That was great. I I messaged one of my friends who so I've been putting together one sec. So I messaged one of my friends because I started putting together a video yesterday about like effectively like why I moved from Unreal to Unity. And it's kind of like the first devlog of of Isekai Crusader Raccoon's Realm Rescue, because he's quite knowledgeable when it comes to this type of stuff. So I figured I'd reach out to him and be like, hey, let me like reach out to him, send it to him, see if he's got any good feedback for me. And I think he didn't realize that I'd like gone live like literally like 5 seconds before he fucking calls. I was not expecting that at all. Yeah. So okay, so today's plan is to have our talk with Arkham, also a fellow streamer, although he hasn't been streaming much lately. So have a conversation with Arkham about the video. Then we're going to do despawning. So ragdolls, when they hit the ground, we want or ragdolls after a certain amount of time of being ragdolls, we want them to despawn. So we'll have to figure that out. Which I actually think is probably going to be pretty easy. We just essentially create a spawner eye component, just attach it to anything or sorry, despawn component, and then we trigger it with a timer. Um, then we pass in delta time and we just add it incrementally to the thing, and then we kill it. Um, then we sorry, brain, sometimes mush. Yeah, sometimes mushy brain. Um, so then we're gonna do after that. Then we'll work on the driving, because right now it still feels like you're a bit on ice, and I would like to change that. So yeah. So to being only somewhat sick now. COVID, it's a hell of a drug. I don't suggest it to anybody. By the way, this is like the most complicated video I have ever made. Um, which which is kind of interesting, because like, to be fair, I've not really done a whole ton of video editing, and that's why this is the most complicated one. This at one point was like, this is not the right one. Let me get this reopened, since Arkham's heating up food and he'll be here soon probably. I think this is one of my best videos so far. Um Again, also, I've not done a whole, like, as far as like composition and whatnot, I think this might be the best one so far. I put a lot of time into this yesterday. like a lot of time. I like actually pulled stuff out and did things and made and put together things. I did green screening and effects and stuff like that. I forgot to do transitions. That's what I did wrong. Ooh, ouch. Ooh. Although when I put it out there and nobody really complained about a lack of transitions. So everything's a freaking jump cut. The lack of cut. There's no cuts. Everything's a jump cut. I bet Arkham's gonna probably say something about that. But yeah, it's just like I forgot to do any cuts at all. It's a short video though. Production ready. List of games that actually uses uh dots though is kind of cool. I think there's two things that I'm kind of happy with how they turned out, and it's this. Mm. And I think this turned out pretty cool. Buffer? Are they telling me that no? Weird. Weird. Anyway, so I got it pulled up. There's so much going on in this. So oops. Let's just mute that. Mute that. I'll come back. So there's so much going on here, which is crazy for me. Okay, so let's go to this one. Each one of these arrows had to be put onto a different layer. Right? So I put each one of these onto a different layer, and then I collapsed them into each other because it was too hard to manage. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 12. I think it's 12. There's 12 arrows. So it was 12 high. And then I wanted to extend it. So I ended up having to have 3 of them. Because this is an extended clip, right? You can't just like make it longer than that. So, anyways, um, where was I? Here we were. All right. So what are we gonna do? We're gonna go to Raccoon scripts. Entities authoring. We need a new authoring. Despawn timer. Nope. We'll add that. Then we'll put our I component data in here. Next timer or despawn time. Max despawn time. We go. And do floats usually equal 0 by default? I think floats should default to 0. Sweet. Okay, so these both default to 0. That's not what I wanted. Ooh, there we go. They want var, right? Yeah. Now we need a system. All right, and then we want this. And entity systems. That's fine. Truck cone. There. Input system. Truck coon. There we go. Despawn timer here. Where's our despawn timer system? There it is. We can grab the pedestrian move system. No, we can't because this one's spawner. Yeah, spawner. Here we go. For the most part, this is all we care about for the despawn. Despawn timer data. To do oh, okay, it's there. And has local transforms. Because if it doesn't have local transforms, then there's no point in despawning it. System API query. This needs to be ref read write. This is ref read only. The only reason we have this is because we need to have 2 in order to do a query. That's fine. This, though, we need to drop, and this needs to be read only. This is going to be ref read write despawn timer data. And we want to make sure we spell ref right. There we go. Wait. What?
Hello, sir.
Hey, welcome to the stream.
Hey, hey.
It's been a while. I'm fairly certain that everybody should be able to hear you.
That's what I'm hoping.
Yeah.
Here to just kind of answer questions. You said you had some stuff you wanted me to look at.
Yeah. I sent you a video.
Yes, you did.
I'm planning on posting this on Wednesday.
Okay.
Probably Wednesday. But I wanted to get your opinion if there's anything that I missed, which I totally realized as soon as I opened it up. I was like, I forgot to do any transitions in this, and everything's a jump cut.
Oh, yeah. Lovely.
Although,
Yeah,
like,
well,
I totally didn't even notice.
Okay.
That's not necessarily a good thing, but I think this is definitely like my most well thought out video so far.
Okay.
Yeah.
So is it more of, I'm trying to see from the thing you sent me. A second.
Yeah, so it's like a devlog. Sort of. It's a devlog. Sorry?
Okay. Was it more of just like you're talking about the intro, like the titles or jump cuts?
No, like well, so like there's no like fade in or anything like that on any of them, so it's just like hard cuts to everything.
Uh-huh. Okay. Gotcha.
But yeah, like you may or may not even notice it. I know I didn't notice it because I've watched it like 6
I
times.
I don't know if I saw any like hard cuts that were off-putting.
That could also just be it.
I think yeah. I mean, the way you talked about it in the video and the way you kind of like ran through some stuff, it it didn't off-put me of like, oh wow, these things are just like, they're here and now they're gone, or they're here and they're there. So
Yeah.
pretty good editing. If you wanted to do some smoother like blend transitions or anything, you could, but it's really your choice.
Yeah. what did you like any of the effects that I did?
For like all the edit cuts with all the like no stops, don't do it. Wait.
Oh yeah. The like guy in orange being like no.
Uh-huh.
he,
Yeah.
he's on
Oh
an
my god.
orange
Just the
background too.
cuts of you running through. I wish I have the same gripe with ODOT of I wish the truck was textured already. But I understand that it's not because this is a test
Yeah.
sequence for the GitHub.
Well, I'm still waiting for it too.
Oh yeah.
Yeah.
It's fun though. No, I think it's a cute video, dude.
Dope.
I wouldn't say there's anything that's like, oh man, you're just missing this. Especially just for what it is too. Like I'm not gonna be so like super nitpicky because you're kind of in like a pre-alpha early stage demo.
Yeah.
That's cool.
Definitely.
Cool shit, dude.
But you like it? I didn't
Yeah.
fuck it up
It's
real
cool to
bad.
see you like coming through on a project so strongly too. Like I love seeing that you're like actually getting to stages where you can show off some stuff versus just like testing all the time.
Yeah. Well, somewhat. I'm gonna do despawning for the ragdolls today, and then probably work on some um fuck. Man, COVID, it's a hell of a drug. I don't suggest it.
Dude, it's so bad. I'm surprised you're still going live while you're still on it or coming back from it.
I mostly got over it on the weekend, but still got a bit of it. Still lingering. Tiny bit.
Yeah. Well, chat, be nice to him. Whoever's hanging
Hell
around. Or if they watch this back later, be nice to him. He has COVID.
Yeah, this is definitely like the biggest edit I've ever done.
How do you feel like doing edits while you're live on Twitch and stuff like this?
Oh, I don't care.
Okay.
I've done them before.
I don't know. Yeah, it's so interesting to me because I feel like the editing side is like the stuff no one ever ends up like seeing very often because they don't do it live; they do it in post, right?
Yeah,
So, kind of interesting that you're live, like showing people how you're going about your edits and your cuts. What are you using for this? Is this Premiere?
DaVinci.
Can't tell. What is it?
DaVinci.
DaVinci. Ah, okay.
Yeah.
I've had some friends talk very highly of DaVinci, saying it's good.
You can't complain about the price.
Well, yeah, fair enough.
But it also is like actually the industry standard for color editing.
Yeah, I heard you like there's some really, really good tools in there. Just that the program ran for it.
Yeah. So like the color correction software for film is
Yeah.
like the best on the market.
Mm.
Like it was
Hell yeah,
used
that's
to color
awesome.
correct like The Dark Knight,
Wow.
right? Like I don't know if they used it. I don't think they used DaVinci for like actually editing The Dark Knight, but they color corrected it in DaVinci.
I mean, if there's a tool you need for the job to get it looking right,
Yeah.
use it, right?
But yeah, like they've been the number one color correction software on the market for like 20, 30 years or something like that. It's just been insane. Like they created the market effectively.
Dude. Yeah, I believe it. There's some good stuff in there.
Yeah. Then Fairlight. Fairlight was huge, and Fairlight's now the DAW that's inside of DaVinci.
Oh,
Yeah.
wow.
Fairlight was really big in the early 90s and stuff like that. They were like one of the first big synths. Yeah.
I did not know that.
Yeah. But
Hmm.
no, it's good, and their editing stuff is been getting better and better. Fusion's also few a lot of people, depending on like where you're coming from, Fusion's either going to be really painful
You're talking
and
about Fusion 360?
no, Fusion's their special effects stuff.
Ah, okay. Okay.
Yeah. So Fusion's either going to be like complicated
Mm-hmm.
and hard to understand, or it's going to be easy to understand and easy to use. And it kind of depends on how you think. So it's an entirely node-based system.
Also, it's your bread and butter, is what you're telling me.
I find it I don't understand most of it because like I don't understand what's going on.
Mm-hmm.
But like the moment I understand what's going on, the process is really easy. It all just clicks super easy for me. So
Yeah. I mean, hell, that makes sense.
yeah. And then like if you do decide to buy um DaVinci Resolve Studio, which gives you a couple extra like AI things and some really good AI tooling around like denoising and
Mm-hmm.
stuff like that, and like green screening and stuff like that. But it unlocks a couple extra features and stuff like that. And if you do decide that you want that, it's a one-time payment and it's perpetual, yeah, including updates.
Hmm.
So it's like, and it's I think it's like $400 American. Like it's not super cheap,
No,
but
for a
like
one time,
one
uh,
time, and
that's pretty good.
people have been using their versions of DaVinci Resolve Studio from like the 90s today with
Wow.
with the most recent version and stuff like that. Like it's crazy. They're hardcore about that support. They're just
I
like,
believe it.
if you buy it once, you get it for life.
That's the way it should be, man.
Yeah, no,
In
I
most things, but
it's fucking great.
I get it. I get it.
Yeah. So I don't know the price. It's hard to complain about. So that's how I got
Mm.
into it, and now I actually have the paid version because I got the speed editor.
Oh yeah.
Yeah, it's like this little specialty keyboard with little macro keyboard with like a wheel to like jump through. So like I can just like very precisely jump between things, and then if I wanted to make like an edit to like this, I can hold a button and then scroll a wheel and it will like make it longer or shorter. Yeah, or
Mm.
cut from the front or add to the back and stuff like that. It's really cool.
That is kind of cool.
Yeah.
Wow.
So yeah, I
Sick.
love it. 10 out of 10.
Awesome. Well, can't stick around for too long right now because I actually have to head out for another appointment for some stuff. But I definitely wanted to pop in and try to answer your questions and check out what you got going on. So it's cool stuff.
Yeah, thanks, man. Yeah, I was. You're kind of like one of the experts when it comes to that kind of stuff. So I was like, if if anybody would be able to tell me whether or not I fucked this up in a very obvious
In
way,
editing, yeah.
yeah,
I'll
it
give it
would be it.
another watch through too.
Yeah.
Um and I'll ping you a note or something if I catch something on like a second through. But initially I was like, kind of fun.
Yeah. Well, I definitely think that it feels the best. Like it feels better than a lot of my other videos. I feel like
Hmm.
there's kind of like I think it's the backing music that I put into this that makes quite a bit of a difference too. But,
The silent opening is so interesting to me too, of the choice.
oh, that was Rem's idea. He's like, "Do it, man. Just push everything else of the silent opening of you just running over a bunch of people."
I mean, it's a choice. It's not bad, and it's not like, I mean, it's just one of those like, oh, you have my attention. What's happening?
That's why he suggested it. Also, Fallon Fox, welcome back. Sorry. Yeah, I know I did it and I was just like, you know what? He was really right about that. That opening really
Yeah,
hooks you. It gets you interested in the project.
it does make me go, wait, what? Like, did I miss something?
Mhm. It's like, I know you see that and you like immediately know what this game is about.
Yeah, I just know it's like a bundle of chaos in the moment.
Hell yeah.
Yeah, I mean that's the crazy thing about video editing is like there's so much freedom of choice for design and approach to how you want to like tell people what you're trying to tell them. So it's kind of cool that you can do a cold opening like that and it still works because people will usually give you how long did you end up doing the cold opening? What are they saying?
I think about
They'll give
five
you about
seconds.
10, 15 seconds before they go yay or nay.
Yeah.
But you did it in 5. Yeah, so a good 5 second opening just to like, whoa. Yeah.
Whoa, that hits home.
Yeah. Hmm. Well, hopefully I can talk with you a little more when you're feeling a little better. Hopefully less coughs and
Oh yeah, that would be fucking dope. I would love to not cough as much.
yeah. But we'll catch
My
up soon. I'll try to
my
pop in and
chest.
around the stream a little more too, but I do have to get going.
Yeah, no worries, man.
But cool stuff, dude.
All right. Thanks so much, man. I really
Yeah, of
appreciate it.
course. Yeah, anytime. All right. Good luck with the rest of the stream. Bye,
Thanks.
chat.
Bye. For anybody that is unaware, Arkham is a very talented artist. Oh, Art Station? If I spell Art Station correctly, here we go. That's not him. Okay, here we go. Let's try that. What? No. Mm, Arkham. Anyways, here we go. Here's his Twitch. I think he's got links to everything on here. I'm gonna give him a quick shout out. But his I don't know why this is in French. Let's see. Ah, here we go. His alt station. He did some work on New World. But his stuff is really good. I remember when he was doing this. This was great. Look how good this is. The man is skilled. He's got the skills. That is the very truth. Is he has a lot of skill. So definitely go give him a follow. His old fantasy world. This sword. You worked a very long and hard time on this sword. Created a lot of things. It's a hero sword. Very high detail. And so much time on it. You did a really good job though. Look at this. Look at the detail on this. If you're not familiar with him, go give him a follow. Subscribe to him on YouTube. Actually, what is his? Is his YouTube the same? I don't remember. Yeah. Oh shit! I forgot to put that in the other one. Oh well. Yeah, doesn't matter. I'll do it. I'll worry about it later. But also give him a if you've got an art station, go give him a uh, give him a little follow of some sort here, or follow him and like his stuff. Get him pushed up there. Do beautiful sword, beautiful work, great work. Oh, that's a cool hammer. Okay. Now we need to get this delta time inside of dots. I know there's a way to do that. Because I want to say that it wasn't just time dot delta time. Hmm. Oh, it's system API time dot delta time. Update current time in Chrono, welcome back. In the spawn timer. Did I make that? That's not correct. There we go. Still down with the sickness a little bit. I'm getting better though. And is greater than or equal to max despawn time. We want to do a destroy dots destroy entity. I imagine it's going to be just system API dot destroy entity. System API dot destroy? No. Where's this cow? Where do I get this? This one, destroy entity, but where does this come from? Parameter entity. Important. This function. How to safely destroy entities. Yeah. Still down, but better than I used to be. And pedestrian. Sorry. How to spawn and despawn entities. Here we go.
Hello everybody and welcome to today's video where I'm going to be showing you how to spawn and destroy entities
Yes, it's 5 years old, but it still might work.
from mono behaviors using the entity manager. So of course,
Wait. This is something that CodeMonkey did.
Hello,
With-
welcome. I'm your Monkey.
Yeah, he did this with his zombie free 7-hour
Those
tutorial.
ones that we just installed. Again, like I said, part of the reason why I told you to wait and then download the exact project file, either selected nor deselected, so both events are set to false. And now, no target. And as I move, and yep, now with burst being disabled, now the errors are much more easily understandable. They are easily understandable, and now we can actually click on it. So we can click and see the error was on the shoot attack system, line 28. Select inside this one, and if here is shoot attack system on line 28. So if you're having trouble debugging something, just go ahead and disable burst. Also, by the way, remember to re-enable burst after you solve that bug. Also here, we can see another very interesting quirk about how dots works. Like I said in the very beginning, dots works very much based on source generation, meaning we write a bunch of this code, and then dots, the dots compiler, is going to run through this code and going to add a bunch more things. So in between you writing the code and the final compilation, the code runs through a system which adds a ton more code onto your code. That is why we have marked this as partial. So as to why that matters is over here in the code, we can see the error is on the shoot attack system on line 28. But over here on line 28, we are just defining a local variable. This line cannot possibly throw an error. So the error is actually not on this line. It's actually on this line over here. So it's on line 27, not 28. Now this is a little quirk of dots that it's very important for you to know. Because of source generation, the lines can look a little bit off. So it might tell you that the error is on line 28, but it might be on 27, 29, or any of the ones that are nearby. So if you are confused, keep in mind that the offending line might not exactly be the offending line. So if you have some error and you don't know what exactly is causing it, make sure you look at the lines nearby, not just the exact one that's on the error. Okay, so anyways, now that we've learned that, let's actually solve this error. So basically the problem is, like I said, is that the unit is
100% true. I've ran into that already.
still trying to attack an entity that no longer exists. So basically, as you cycle through multiple units that are shooting the same zombie, eventually one of those units is going to destroy the zombie, which then runs the health data system, which is going to destroy that entity. But then the next time this one runs, the other entities that still have a target, the target is not null, it is simply pointing to a target of an entity that has since been destroyed. So we basically need to validate the data that we have inside the target components. And again, we could write it directly here, or we can make a dedicated system to do that. So let's do that. On the systems, let's construct a brand new, go into entities, a new system. Let's call it reset target system. And for this one, let's cycle through everything that has a target. So doing a system API, doing a query, let's read and write on the target component. So for each ref rw on the target and call target. Okay. Amount if that one is under or equal to 0. If so, then this entity is dead. So this is where we need to destroy this entity, which means it's actually a great time to learn one thing, which is how exactly do we get the entity reference. Here we are doing a query, and we get the component of the query, but we don't actually get whatever is the entity that this query, that this component is attached to. If we go inside the health, nope, we have no reference to any of that. There's no reference to any entity. Even on the value row, we still
Oh, wait. One sec. Oh, I think we can get away with this. Hell yeah.
have no reference to the entity. So over here on the query, we are just getting components, and we can't really just write with entity access. So we use this one anyway. So let's put it to be at the end. We cannot place this one. Okay, great. So state. And if we access that state, inside there we have the entity manager. So that is the entity manager where this system is running. And within that entity manager, we can call the function destroy entity. So like this takes an entity, so let's destroy this entity.
Huh. So it's not system API, it's state. Wait, this is a system. Oh, that's not what I wanted. No, I wanted like a regular one. Struct. Not a class. Struct. Was it entity manager? Not destroy entity. There we go. Think it was ref before state. Ref before state? Systems? System state. Oh, yeah, you're right. Thank you. Oh, and we can burst compile. I don't actually think this is going to burst compile. I think this is not burst compilable, but whatever. Just because we're actually accessing the entity manager to do the delete. But this isn't something that happens super often. So we can just skip over it. We don't care that this is going to be a little bit off. Like this can be a little bit off or very accurate. It doesn't matter. So there. When we come over to here, we come down to our AI pedestrians in our prefabs here. And this needs to be added to the despawn timer. 5 is fine. I forgot that I had made a default on that. There we go. So now when I run into one of the girls, after she ragdolls, she should despawn after a while. Structural changes not allowed. Oh. Wait. Here we go. Huh. What does this say? Ooh. Um. uh. Do. Let me go back and read this one more time. I wish that this was larger. Does anybody know if there's a way to make these larger? Invalid operation exception. System invalid operation exception. Structural changes are not allowed while iterating over entities. Please use entity command buffer instead. Entity command buffer. I think this is like a larger in that way. Oh, like just the text. I think the text is a bit too small in these. And I feel like it would be under preferences or something like that. Maybe. So hoping just to make it a tiny bit larger. I'm not seeing anything. Oh. Sorry. Oh wait, I forgot to do something. And this is actually important. I totally forgot about the only thing I know, make everything in your editor bigger. Oh, it's kind of poopy. Maybe not the absolute worst, but still a little bit poopy. Package manager. And it's this one. And it's project auditor. Is it not that one? Yeah, they really do. Huh? I thought the wait. Unity project Unity 6. Oh, you have to do all of that? Interesting. Ah. I didn't realize that you had to do this. That's interesting. Okay, so we do this, then we come back into here. Sorry, that's my bad. Okay, so we come into here and we click the plus, you said? Add by name. Install. I think this should just ship with it enabled, like installed and enabled by default, to be honest. It's not like like this isn't getting in the way of me being able to develop something. So like interesting. Okay. Right. We were also looking at command buffers. Entity command buffers.
Hello everybody and welcome to today's video. We're going to be talking about another frequently used and important concept of Unity's entity component system, which is entity command buffers. Now, entity command buffers work very similar to entity.
I think in this state we would need to have in this case, because I think
managers, where we can modify entities by instantiating them, destroying them, adding, removing, and modifying components, all sorts of fun stuff like that. However, entity command buffers do address some of the issues with entity managers, which we talked about in the previous video that I did on entity managers. Now, you don't necessarily need to have watched the entity managers video before watching this video, but I do think it will provide kind of some extra context about how all this stuff works. So feel free to just open it up in a new tab. I'll leave a link down in the description below. You can check it out afterwards. So in today's video, I'm going to be talking about entity command buffers, a little bit about how they work and how they solve some of the problems with entity managers, and then I'm going to be actually doing a little tutorial section to show you how to actually implement this in Unity. Now, if you do find today's video helpful, I'd really appreciate it if you hit that like button. Also, feel free to subscribe to the channel for lots more videos about Unity's entity component system and their data-oriented technology stack. Of course, if you have any questions for me or suggestions for future videos, you can always leave those down in the comment section below, or come join us over on Discord over at tmg.dev/discord. All right, so first off, what is an entity command buffer? So as the name suggests, it's a buffer that stores commands for entities. So really what that means is it basically just queues up structural changes, and then we can execute them all at once at some predetermined sync points in order to have better performance in our game. I talked a little bit about sync points in the previous video, but basically these come up when we want to make structural changes to entities. Now, these structural changes always have to happen on the main thread, so this basically means it needs to wait for all scheduled jobs to complete before running these. So it's kind of like a little bit of a bottleneck in our code. So basically we want to have as few of these sync points as possible. Now again, with the entity command buffer, we can basically queue up all these structural changes. So when we're doing like multi-threading and stuff like that inside jobs, we can queue up all these structural changes, and then when we get to a predetermined sync point, when we kind of agree that this is a point in our code where it's okay to wait for everything and run a bunch of things on the main thread, we can basically just play back all those changes that we've queued up in our entity command buffer. And the main things that you're going to be doing with entity command buffers are creating and destroying entities, as well as adding and removing components. And if you'd like, you can also queue up setting components so that they can happen at a predetermined point in your code rather than immediately during the job. Now, the entity command buffers solve two major problems with entity managers. The first being we can actually run entity command buffers inside jobs, whereas we can't run entity managers inside multi-threaded jobs. If we were to try to do it inside like a for each query or something like that, it only allows us to do it if we were to run it on the main thread without the burst compiler. With the entity command buffer, we can basically queue up as many of these changes as we want inside any job that we want of any system, and then at a predetermined point in time, again, those changes are going to be played back. And the other problem that it solves is it reduces the number of sync points. Basically, any time that we use the entity manager to make a structural change, it's going to create a sync point right there in our code. Now again, if we were just to do some simple structural change using the entity manager, we're going to have to create a sync point, and we're going to have to wait for all scheduled jobs to be completed before we can actually proceed with making that simple structural change. So the advantage with entity command buffers is we can basically group all these changes together, and then we're going to execute them at a predetermined point in our code. Now by default, there's 6 sync points that we can take advantage of during our code. So one thing that you may know is we can actually group system into different groups in our code, and that basically determines the order of execution where they run throughout the lifecycle of the frame. So we have three main groups. We have the initialization group, the simulation group, and the presentation group. And basically we can run our systems in any one of these groups. Now there's a sync point that's going to be executed at the beginning and the end of each of these groups. And then so if you do the math, 3 by 2 is 6. So we immediately have 6 basically, sync points and kind of default entity command buffer systems that we can work with. And if you want, you can actually create your own entity command buffer and execute it at, whatever time you like. It doesn't necessarily have to be in one of these predetermined points. But again, that's just adding another sync point to your code, and we want to minimize the number of those as much as possible. So for example of what one of these systems would look like, I'll be showing you this when we get to the tutorial section. But if we have the simulation system, probably the most common entity command buffer that we're going to be using is the end simulation entity command buffer system. Now basically this is the system that runs at the end of the simulation system group, and then in that point we basically would create a command buffer for that system, and then once that system runs, it's going to play back everything that we've queued up in our command buffer. So by creating these different command buffers, we can kind of determine at what point in our frame we want these changes to actually be executed. And again, by default we have 6 of them. Now another advantage of entity command buffers is they basically do the maintenance work once our queue is empty rather than after every single structural change. So if we're just to do some simple changes with the entity manager, it's going to have to do a little bit of cleanup work after it does every single individual one of those. Now with the entity command buffer, we can basically run through, the entire list of commands, and then once that's complete, then it's going to go through and do the maintenance work at the end. So, again, we're reducing a whole bunch of complexity during this. Now, like I mentioned in the entity managers video, there's kind of like a hierarchy of how you should make changes using entity command buffers. Now with the entity manager, basically, ideally you'd want to make changes on a full entity query. If for some reason that wasn't possible, then the next best thing would be to do it on a native array of entities. And then finally, the least preferred way to do it is just by doing it on individual entities. Now with the entity command buffer, it's going to be pretty similar. Ideally, we're going to be wanting to run changes on a full entity query. That's going to be the most efficient. Unfortunately, we can't run entity command buffers on a native array of entities. However, we still can run them on individual entities, and I'll be showing you how to do both when we get to the tutorial section of the video. And that's basically it. The only other thing that we need to keep in mind is that things are a little bit different depending on if we're doing these entity command buffers on just kind of like a regular main threaded job versus a multi-threaded job. Again, when we get to the tutorial section, you'll see how that's all done. And in fact, the tutorial section starts right now. So we're over here in Unity, just of course have a simple little scene set up here where I just gonna have a plane and a couple of these red capsules that are labeled as entity spawners. All they have is an entity spawn data script on them, and we can see what that entity spawn data component looks like. Basically just have a public entity, essentially a prefab for the entity that we're going to spawn. We just have a delay of how long between each entity that we want to spawn, and then finally a timer to just keep track of that count. Okay, now then, so this is the spawner control system. Basically this is going to control when we want to spawn and not spawn entities. One thing you'll see that I'm doing an update in group type of initialization system group. So this is basically going to be running towards the beginning of the frame, and then basically the reason we want to do that is because this is kind of like collecting input from the player and telling these spawners that they should be spawning entities, which will be happening later in the frame. So we want this to kind of happen early on in the frame. So now this is one of those instances where we actually do end up using some local variables inside of a system. So we're just going to make a private end initialization entity command buffer system. I know that's kind of a wordy type, but we can just kind of break this down. So this is happening at the end of the initialization system, and it relates to the entity command buffer system. So this isn't the command buffer itself, but rather this is the system in which the entity command buffer system runs during the end initialization phase. And so we can just give this a name of end initialization entity command buffer system. Now in the onCreate function is where we actually want to get a reference to the actual system. So we'll just type in the name of the variable, and we'll set this equal to world.getOrCreateSystem, and then inside the type brackets, we're just going to put the type of the end initialization entity command buffer system, and that's all we need to do like that. So again, that's just getting reference to the system. Now in the onUpdate function, here's where we can actually create the command buffer. So basically we can just do a var, and we'll just call it ECB for short, and then we'll set this equal to our end initialization entity command buffer system dot create command buffer. And that's basically all we need to do to actually create the command buffer. So now we're going to actually go ahead and add some things to this command buffer. So in this case, when we press the Y key, we're going to add a tag to anything with the entity spawn data, which of course we get in this spawner query right here. So we're basically just going to add a tag so that when we go to our spawn entity system, it's going to actually spawn entities because it has that tag. So to do this, we can just do our ECB, which again is our actual entity command buffer dot add component. Just inside the type brackets here, we can look for the should spawn tag. Now inside the parentheses, here's where we actually put either the individual entity that we would want to add something to, or in this case, the entity query, which is going to be the spawner query. Now we can do something very similar when we press the N key. So if we want to say remove some components, we can do ECB dot remove component, and then just inside the type brackets here, again, we can just do the should spawn tag, and then finally we're going to put in our spawner query inside the parentheses here. So again, basically this is going to just queue up all these changes. So it's not actually adding components at this exact point in the spawner control system. It doesn't actually add these until the end initialization entity command buffer system runs. And I see that if I come back over to Unity and I press the Y key and the N key, you'll see that nothing actually visually happens. That's because we haven't set up our spawning system quite yet. Now if I were to select one of the entity spawners from the entity debugger and I press the Y key, you see that the should spawn tag is added, and I press the N key and it is removed. Also over in the entity debugger, I just want to point out this is the list of all the systems in our current world. You see that the initialization system, at the very beginning of it, we have the begin initialization entity command buffer system, and then down at the end we have the end initialization entity command buffer system. And the same is true for all of the other defaults.
Wait, I feel like he should be covering that here as well.
Okay, yep, that's brilliant.
Yes.
However, this will throw an error, but let's try it anyways just to see. Let's say
Oh, okay.
so here we are. Let's select the zombie so we can see it. Let's inspect the health of the zombie. Okay, like that. Let's approach with a bunch of soldiers. And they're close enough. They are shooting. And yep, the health is counting down. So let's see what happens when it gets all the way down to 0. So there you go, like that. And yep, we have an error. Here it is. It is saying structural changes are not allowed while iterating over entities. And then it says here, please use an entity command buffer instead. So again, the error is because destroying entities is what is known as a structural change. I already talked about what those are a while ago. I mentioned why we use an enable component for the selected instead of adding or removing components. So here it's really the same thing, except instead of modifying the components, instead of adding or removing, instead of that we are destroying an entity, which again is also a structural change. When we destroy an entity, that means that dots on the backend has to reorganize all the memory arrays. They always all need to be tightly packed. So if one entity is destroyed, it needs to move all the other entities in memory. Now if we do that here inside the for each, not only is it a costly operation, but it actually breaks our code in this case. We cannot be cycling through something and then basically modify that collection. Now the solution here is actually quite simple. We don't really need to destroy the entity immediately right here. Instead, we can essentially queue it up for destruction. So we can do all our health testing logic. We can identify which entity should be destroyed, and then after doing for each, afterwards, then we can actually destroy those entities. So the way we can queue up commands is something known as an entity command buffer. That's basically a buffer for queuing up entity commands. And for using an entity command buffer, we have two options. We can manually create a brand new one, or we can choose one of the ones that already exist. Let's see both options. So first, let's see the manual one. So up here before our for each, let's construct a new entity command buffer. For that, we do a new entity command buffer just like this. And this one, as so many things, takes an allocator. So allocator, and let's use the temp like we're used to. Let's just add the using statement for these up here. So using unity.collections, okay? So we have the NT command buffer, something like this. And then down here, when this entity is dead, instead of destroying it instantly through the entity manager, instead let's just destroy it on the NT command buffer. So here, let's go and destroy entity, and let's destroy the exact same entity. Again, importantly, this is not actually destroying the entity right here. It is simply queuing up that command. And then down here, after we exit the for each, over here, let's access our NT command buffer, and let's call playback. And this one takes an NT manager, so let's state.NT manager, and if like this, it won't work. So we construct new NT command buffer, we queue up some commands on that buffer, and then we tell it to playback, which essentially means that the NT is going to run all of these queued up commands, and is going to execute them on this NT manager. So this way, we are no longer destroying entities in the middle of
Wow,
for
that
each.
didn't
We
take
simply
long
queue them
at
up and then
all.
destroy them all. Okay, so let's save and let's test. Okay, here we are. Let's approach the unit with all of these. Let's see the health amount going down. Okay, it's all going down 60, 50, going down to 0. And yep, it did work. We did not have that error. If we look in the entities hierarchy, we can see, yep, the zombie unit is no longer existing. So that's great, that part works. But we did have a different error. Like it says here, the entity does not exist. So we are trying to do something with an entity that does not exist. Basically, what happened is the entity was destroyed, but then we still try to do some logic on that destroyed entity. That's why we have this error here. And also, by the way, this is a great time to see something very important about debugging. Right now, if we select this error and we look down here, we can see this error log, this stack trace looks very strange. Look at all these very strange names for the functions, for the class names, the lines, and so on. All this looks super strange, and none of the links are clickable. So for example, over here, I can see some error happened on the shoot attack system, and usually you can click on this in order to go to the offending line. But right now we can't really see that. This has to do with the fact that we are using burst. Now burst makes it super fast. It applies tons of optimizations to your code, which makes them insanely.
The kind of shitty thing is that account is already dead, right? That bot is already banned. It's already it's a dead bot. Like banning it doesn't do anything.
Fast, but at the same time, the downside is that it makes it quite a bit hard to debug. So if you're having trouble debugging something, then the simplest option is run to just disable burst. So let's stop playing. Let's go up top to jobs, burst, and let's not enable compilation. Okay, let's play again, and let's trigger the exact same thing, get them all close enough to shoot, and now let's wait for that unit to be destroyed and throw the error again. Here's the error again, and yep, now with burst being disabled, now the errors are much more easily understandable. They are easily understandable, and now we can actually click on it. So we can click and see the error was on the shoot.
It's a little bit more complicated than that, but yes. Twitch chat is IRC. Yeah, no. Twitch chat is effective, is an IRC system. It actually follows the IRC protocol. Now, it has some extra stuff that it's tacked onto it, but it is just IRC. There's some new authentication systems that they've tacked on since the last time I did a bot, built a bot for Twitch. So like I when I first started, I was building Twitch bots. I don't think any of them work anymore because Twitch changed the way you would do authentication. But yeah, so you know, it is what it is. It's so cheap. It's
shoot attack system, line 28. So let's go inside this one. Hey, up here is shoot attack system on line 28. So if you're having trouble debugging something, just go ahead and disable burst. Also, by the way, remember to re-enable burst after you solve that bug. Also here, we can see another very interesting quirk on line 28%. Get them all close enough to shoot, and now let's wait for that unit to be destroyed and throw the error again. Here's the error again. And yep, now with burst being disabled, now the errors are much more easily understandable. Can click.
wait, what just did I let it go too far, didn't I?
Let's just get rid of this out. Okay, so let's test. Okay, so here we are, and no one's finding targets, no one's shooting. So now this one, some bullets deal some damage, something like that. We're actually going to spawn the bullets in a little bit. In order for those bullets to deal some damage, we also need to implement an actual health system. But for now, let's just do a quick test, just make sure this is working. So debug.log, and once again, this implemented system.diagnose that is not what we want. So let's do using Unity engine. So do a debug.log and say just shoot. Okay, let's see if this log does show up. And over here on the find target system, let's just get rid of this log. Okay, so let's test. Okay, so here we are, and no one's finding targets, no one's shooting. So now this one, as this one approaches, it should find target, and what happens when it hits 0? And that we are destroying an entity, which again is also a strike. So we are trying to do something with an entity that does not exist. Basically, what happened is the entity was destroyed, but then this system is running, and within that entity manager, we can call the function destroy entity. So like this takes an entity, so let's destroy this entity. Okay, yep, that's really it. However, this will throw an error. Thing, except instead of modifying the components, instead of adding or removing, instead of that, we are afterwards, then we can actually destroy those entities. So the way we can queue up commands is with something known as an NT command buffer. That's basically a buffer for queuing up NT commands. And for using an NT command buffer, we have two options. We can manually create a brand new one, or we can choose one of the ones that already exist. Let's see both options. So first, let's see the manual one. So up here before our for each, this entity is dead. Instead of destroying it instantly, right here, it is is going to run all of these queued up commands and is going to execute them on this NT manager. So this way we are no longer destroying entities in the middle of the for each. We simply queue them up and then destroy them all. Okay, so let's save and let's test. Okay, here we are. Let's approach. Look in the entities hierarchy. We can see, yep, the zombie unit is no longer existing. So that's great. That part works. But we did have a different error. Like it says here, the entity does not exist. So we are trying to do something with an entity that does not exist. Basically, what happened is the entity was destroyed, but then we still try to do some logic on that destroyed entity. That's why we have this error here. And also, by the way, this is a great time to see something very important about debugging. Right now, if we select this error and we look down here, we can see this error log, this stack trace looks very strange. Look at all these very strange names for the. It applies tons of. They are easily understandable, and now we can
that's why.
so we can. It's very much based on source generation, meaning line 28. But over here on line 28, we are just defining a local variable that are nearby. So if you are confused, keep in mind that the offending line might not exactly be the offending line. So if you have some error and you don't know what exactly, which then runs has since been destroyed. So we basically need to validate the data that we have inside the target components. And again, we could write it directly here, or we can make a dedicated system to do that. So let's do that on the systems. Let's construct a brand new, go into entities, a new system. Let's call it reset target system. And for this one, let's cycle through everything that has a target. So doing a system. So the way we do that, let's simply and actually I'm going. Let's just learn more about the NT command buffer. So here this code is if you look over here on the entity hierarchy, we can see, yep, the zombie unit no longer exists. However, we still have a bug, which is the visual. The visual mesh was not destroyed. We're going to handle that in a little bit. But the important thing right now is that we did destroy the main entity and it did not throw any errors. Okay, so before we solve that visual bug, let's just learn more about the entity command buffer. So here this code is working. We made it work by using a custom created entity command buffer. This works. However, another option, which actually works best, is to use one of the preset entity command buffers. If we start playing the game, let's pause and let's look over here in the systems window. And if we scroll down, we can see we have a bunch of entity command buffer systems. So there's one over here on the begin simulation and one over there on the end simulation. Basically, we can reuse this one instead of creating a new custom entity command buffer. The benefit of this approach is basically to limit when you do structural changes as much as possible. So rather than a bunch of systems all doing structural changes in multiple places in the same frame, instead of that, we can all run all of those commands just at the end of the frame. So the way we do that is we access that entity command buffer, and that one only exists once, so that is going to be a singleton. So let's go through system API, call get singleton, and the type that we want is called end simulation entity command buffer system. Now here, an important thing, it is not just like
Okay, give me a second. This is actually the one that I want here. This will be I don't need that. Get end simulation entity command buffer system. System API dot get singleton. End simulation entity command buffer system.
this. Nope, we need to access through this one and access the singleton that exists inside of this one. So yep, that gives us these.
Oh, dot singleton. Interesting. Dot singleton.
Singleton. And now within, we can call the function create a command buffer, and this one just takes in a parameter for an unmanaged world. So for that, we can access the one inside state.world unmanaged. And that's it. So this will now. And now within, we can call the function create a command buffer, and this one just takes in a parameter for an unmanaged world. So for that, we can access the one inside state.world unmanaged. And that's it. So this will now give us an entity command buffer. So let's use that instead of creating down. So yep, just like this.
Okay, and this is going to give us a entity command buffer. Okay, and then this is a dot create command buffer and state dot world unmanaged. Here we go. I don't like where that did the break. I think that is a better break. And then we will bring that down like that. Not my favorite. I don't like how big this is, but we'll just say command buffer. The yeah, it was a bit too long. There we go. What are you complaining about now? Oh. Here we go. And then here we do let's say command buffer dot destroy entity, and then we pass in entity, and then we have to come out of the for each loop, and then we do entity command buffer dot playback entity manager. There we go. Beautiful. Oh, I found a better way. I found another way. And this might have changed since he did it last. Since he made this tutorial, there is a native debug mode. Yeah. So that you don't have to disable to get it to work. You can just go into native debug mode now. I imagine this slows things down a lot. Actually, I imagine this is why some of my stuff has been slow. But it gives you burst compile. You don't have to disable and enable it. And that way, if you're doing builds, right, you don't have any weirdness. But yeah, beautiful. Attempt to call playback on. What? That should be the last one. Did I call it more than once?
We do this, we queue up the commands as usual. Then the important thing is we do not manually call playback. Again, like I said, this one will run automatically at the end of the frame. Okay, so just like this, let's test. So here we are.
Oh, okay. 30 seconds in the future. 30 seconds in the future. Don't listen to me. Don't. No worries. She should be disappearing soon. There she is. She disappeared. It worked. What was that? Might be an epic. Hell yeah. Come get some. All right, let's create a commit to mark this amazing event that just happened. Hey, I didn't try and type in my old team's initials for my commit this time. we used to I would tag all of my commits with the ticket number. So like depending on your team name, it would be like, it'd be 3 characters and then some numbers. So it'd be like, 3 to 4 letter numbers. I think we're in the thousands. And then my comment or my ticket details here. I've literally just never gotten in the hang of using GUIs, to be honest. Forget, they just don't make sense to me. The only Git GUI that I've ever used is SourceTree, and I find it very complicated. I don't even use I use command line Git to resolve conflicts because it's easier for me to understand. I just have not had the need for command line, so I never learned it. That is entirely fair. I started when I started learning Git. So I use command line first a lot. And I know Vim as well because I needed to. It was part of my job before I started programming. I was doing like entry-level system administrator stuff, like super entry-level stuff. But I was working in a data center. And you couldn't guarantee, the only thing that you could guarantee for an editor that was on your system was VI. So you effectively you had to learn VI at some point, right? Because not all Linux distros come with Nano. and you couldn't install software on a customer on a client system without their express permission. Unacceptable. You're not allowed to do that. So installing Nano in order to, edit a file or something like that, if requested, is just it's not acceptable. You're not allowed. So Vim and VI were always installed because they come with Linux. It's weird when they don't. So you had to be able to use Nano. You had to be able to use VI, VI/Vim, right? Effectively the same thing, but a little bit different, but effectively the same thing. Just because those are the only two things that you would be guaranteed to have, like the only two editors that you're always guaranteed to have access to. Then I was writing software on a remote computer for tooling. I was writing a tool on I was building like my first thing utilizing a tool. No, I learned command line Git because it was just more useful. Sorry. So at the time I was like, when I started learning Git, the reason I started with command line and I always just kept with command line was because I could never guarantee that I was going to be on a system that had a GUI of any kind, right? Like I not all the systems that I'd be on had a monitor attached to them. So when you're remoting in, you don't have anything other than command line, right? So yeah, I was just like, I have to learn, like I have to have command line tools. So yeah. No, I'm with you 100%. Like it's weird. It is what it is. Despawns. Despawn for ragdolls now in place. Sorry, it took me a lot. It took me a little bit longer to remember that than I figured it would. Yeah. By the way, I'm gonna be releasing my first devlog for this game on Wednesday. I'm planning for Wednesday. Right now, it looks like Wednesday, because I'm gonna have to. I've got to return my laptop from my old job today after work. I've got to go down to the Purelator and ship it out. So I've got to make a I have to make a thumbnail. So I'm gonna make a thumbnail later today probably, and we'll see how well that goes. So yeah, so I'll have a video out. It's gonna be the most it is the most complicated edit I've ever done in DaVinci or any editing software. I've never done an edit so complicated. Because like there's multiple effects, multiple different layers of effects in some a couple different layers of effects in some cases, I think. But like I think the most that I've had is like maybe one or two effects in the entire thing. And for the most part, a lot of my stuff is just being like just flat, just edit and just don't worry about anything. Just edit it together, right? Just timeline stuff. And then this one's like, and it's usually like very flat, right? Like I can pancake edit the entire thing. This is a new word that I found out, where it's just like effectively just like one giant timeline. And this one's like an actual timeline. And it's just like, oh, interesting. Yeah. Like this it got huge at one point. Like I think I was up to like 15 different layers on the video, and I was just like, this It's too much. I don't know how to manage this. So you have a hamburger instead of a pancake? Yeah, something like that. I don't know. It's more like a flame chart. It goes like this. I added extra audio channels, something that I've not usually done. Um or at least not really done much of. I did a full voiceover rather than like a talk while I'm doing it kind of thing. So I did a voiceover and then I put the video over top of the voiceover. So I edited together a voice, like a voice line, using and chopped it up and pushed it together and then turned it into like one voice line. And then I took that and then I edited across. I edited all the video aspect of it afterwards because it's effectively like not quite, it's not a talking head, right? So like you don't do the video, you don't have to do the video and audio together. And I figured that if I do the audio first, that will dictate to when certain things would happen in the video anyways. So like I can't edit the video, like can't do the video ahead of time because I don't know when certain parts are going to be needed or exactly what I'm going to say until I've said it, right? So, and if I've said it, I might as well have recorded it. So, yeah. And I spent a good portion of the day like writing and rewriting and doing scripting and stuff like that. This is being the most involved video I've ever done. But I'm really happy with it, and Arkham said nice things about it, so I'm really happy about that too. He didn't critique my audio this time, which is fucking amazing. It was so hard. It was so hard. This the speed editor was great though. Learned some new shortcuts. I got better at some stuff, so yeah, it's coming along. It's there. I'm gonna try and get it out on Wednesday, and it'll be live on YouTube on Wednesday. I suggest that everybody watch it and like it. Would be grateful if you watched it and liked it because it would be nice to get it out there. I think it's like a minute and 30 seconds long or something like that. It's really short. It's so short. How long was it? It's like a minute and 8 seconds. So short. Super short. One of my friends was suggesting that I do a vertical edit of it, and I think I might be able to get away with that, but we'll see. I think a lot of it can be centralized. Yeah, just to put it on shorts. I think his suggestion was TikTok, but I don't use TikTok and I will never use TikTok. So TikTok's not an option, but Twitter is. So I'll probably put it on Twitter. If I make a vertical one of it, which I'll try and do later tonight, I'll put it on Twitter. All right. So now that we've done that, we've got the despawning happening. Oh, interesting. Is this that edit thing? Move. What was it? It was the move. It was ragdoll, move, trigger, system. Yeah. Why is this not happening in create? Okay, so we do an on create here. Sorry, public void on create. I don't think that was the one that I wanted. What was the complaint? No, I lost it. Scroll up. No, yeah, it's gone. I feel like the despawn system has something. No, not quite. What was it? It was get component. Yeah, it was this. This one has it. Oh, that's what it is. Maybe? Oh, right. You and you're being smart about this. I just got to remember where it was. Unity audit.
As soon as you're done watching today's video, I want you to install this package into your current project.
I think I'm blind. Oh, window. Window, analyze. Analyze. Audit. Project auditor. Start analyze. Analyze my project. Go. Mush computer, mush. Faster, do the thing. Look at that. There's only 43 majors. Empty monobe. There's 7 of these. Boxing. Value type such as an is converted into object of reference type. Boxing happens when a value type such as an integer is converted into an object of reference type. Interesting. I think I know where this is. Wait, detail. Oh, wow. Look at that. There's a box cast? I didn't even know that I was using box cast. I feel like I'm not using box cast. I don't even know if I'm using this. I'm gonna be honest. I don't know if this is me or somebody else using this. Yeah, no, some of these might be unrelated to my project. But I think there's a way to like prevent certain code from being this is a Text Mesh Pro thing. Okay, I need to do that thing where we I think this is also Text Mesh Pro. What is this? Yeah, Text Mesh Pro. I need to just remove certain things from my thing here. This one here, I believe, is going to be a plugin. No, this one's from Unity. You will need text. Oh, I'm not going to remove it. No, I mean like remove it from the analyze. Like it's not my code, so I'm not going to edit it, kind of thing. Ooh, this one here. This one, I think this could be me. This one's not me. What was this? This is oh, this is the animations. This is just animations. None of this even matters. Hey, so far I'm pretty happy with what we're seeing here. So far what it states is that that I'm doing a pretty decent job here. Okay, so I think this guy actually goes
Project,
into
run
detail.
it, then come back here and in the comments let us know if you're able to optimize your project at all. What we're looking at today is Unity's new Project Auditor package. This is a free static analysis tool that scans your Unity project's files and code to help you find potential problems and areas for optimization, and then it gives you recommendations on how you can resolve anything that it's suggesting. It works on code, shaders, assets, audio files, and even your built game. So let's get into it. First and foremost, this tool is made for Unity 6.1, but it does work in earlier versions. As you can see, I'm using Unity 6 right now. It should work in some earlier versions than that as well. To get started, head over to the package manager and install the package by name, com.unity.project-auditor. It just takes a minute to install, and before we start using it, I want to jump over into Preferences. Here in Preferences, you're going to have a new section that's just for the project auditor. The defaults are okay, but make sure that Use Roslyn Analyzers is checked. Without this checked, we're going to miss out on an important feature, which is detecting...
Oh, okay. Sorry, what was this? I'm going to come back to that. And now we are going to... This is...
.unity.project-auditor. It just takes a minute to install, and before we start using it, I want to jump over into Preferences. Here in Preferences, you're going to have a new section that's just for the project auditor.
Oh, okay, so this is Edit Preferences. Profile? No. Project Auditor here. Yeah. I'm willing to take this suggestion.
Auditor, the defaults are okay, but make sure that use Roslyn Analyzers is checked. Without this checked, we're going to miss out on an important feature, which is detecting problems with domain reload. Now let's start using the tool. You can go to Windows under Analysis, where we normally find the profiler and whatnot. Here you can now open the Project Auditor. This will bring up a new tab that you can dock if you want. I'm just going to leave mine as a window for now. You can see right up in the top right-hand side here, we've got three main choices. Two of them are grayed out. First is to start a new analysis. The second one is to load one that you've saved. And the third one, of course, is to save the one that you have open. When you save these, they'll save as a nice little JSON file. And this is great if you have a CI.
Yeah, I've watched some of his stuff before. I didn't know that I wasn't subscribed to him. Yeah, he's got some good stuff on patterns. His patterns video are good for whatever you're doing. Like, it doesn't matter what engine you're in, it just matters that you're doing it. Where's his pattern series? I could have swore it was this guy that had the pattern series. Yeah, here, like strategy pattern, and stuff like that. Command pattern. These are great. It doesn't even matter what engine you're using. These are, all of these like transcend they're just like good. This is how I got turned on to this guy initially.
CI/CD pipeline, and you want to start comparing between builds. Now I decided to start this video with an empty project because I know the number of issues will be low. So let's click Start Analysis. It'll take about 2 minutes, so I'll just fast forward here. Then we'll get our summary. So at the top here, you can see we have an issue breakdown. You can see right now I have 0 code issues, 0 asset issues. That's because I haven't brought in any code or assets into this project. But you can see there's 12 recommendations for project settings. Below the issue breakdown are the top 10 issues that this tool thinks that we should look at for some optimization. You can expand any of them to get the details of what it's saying and the recommended action that you should perform. So here's telling me that texture streaming is currently disabled in quality settings. If we open up number 2, it's saying that every box in the layer collision matrix is currently ticked, which increases CPU work. Recommendation, uncheck everything that you don't need. Over on the right, you can see there's a button for more details. If you click that, we'll go into a more detailed view. This button actually corresponds to the sections on the right here. So now I'm actually in the project settings area of the report. Here is a breakdown of every single thing that it's suggesting for project settings optimizations. And you still see the details and recommendations here. Below the recommendation, you can also choose to ignore the issue if it doesn't really apply to you. If you double click on the issue that you're looking at, it'll take you right to the project settings where you can make the adjustments that you want. And the same is true if you were looking at issues with assets or issues with code. It would open up the code in your IDE to the exact line of the problem. So here, for example, it opened up physics settings where I can just go into the settings panel and make some adjustments to the collision matrix. The same would be true if I double clicked on the issue above that. The optimization for the rendering path is found in the graphics settings. Before you start randomly applying all these recommendations, though, actually read what it's saying in the details in the recommendation section and make sure it's actually appropriate for your project. For most of these issues, on the summary page, there'll be a link to the documentation. So if you don't understand what something means and you're not sure, you can use this as an opportunity to fill some gaps in your knowledge. Personally, I think
this is a great tool, by the way. I think Unreal needs this tool.
Invaluable. So that's a basic overview of this tool, but let's start seeing what it can do for our code. The tool can report issues related to the C# code in your project. Most of the suggestions will appear here in the code summary, but we also want to take a look at the domain reload section. This section will report on any static variables or events in your project that aren't getting reset properly. Most of us already turn off domain reload so that we can go in and out of play mode really quickly, but it's very easy to forget that Unity does not guarantee the resetting of static events or variables. Let's write some code that will create a problem. First, I'm going to make a static integer. You can see Ryder already is warning me about it, but let's just continue. We'll have a start method where issues. Number 2 is that the problem was happening. Now, log with a runtime initialize on load attribute. Let's go into the code section of this report. Here you can see I have 2 minor issues, and both of them have to do with the debug.log statement. Not only was I concatenating 2 strings.
Wait. Right. He covered this a little bit already. Let's go back into the profiler. Project Auditor. New analyst. Discard. Ooh. Okay, no. Okay, so I think what we need to do is we need to go through and we need to flag all of the Text Mesh Pro ones, and with the others tools that are not ours, we need to flag those as ignore, so they don't show up again. Because we don't want to muddy the waters. I'm not going to be editing their code, so. Okay, so if I go to code and I click on this is Text Mesh Pro. That's Text Mesh Pro. Okay, so here we can see that it is ignore. Ooh. This one here, I might keep. What is this? We'll keep these ones. What's this one? Text Mesh Pro. Yeah. Ignore. Text Mesh Pro. Fucking Text Mesh Pro, eh? Come on. Custom gizmos? Oh, wait. That one's actually mine. That one's this. So we'll ignore that one. Custom gizmos wheel. That one's Text Mesh Pro. That one's mine. Text Mesh Pro. Text Mesh Pro. You said by group? Wait, what? Wait, what? You can change to go by file name next to the refresh button. In the middle? Oh. Oh. Bet this is Text Mesh Pro. It is. This is. We're going to leave that one. This one here, UI controller. Conversion from value type float to ref type. Interesting. We can't change this one, right? Oh wait. Oh, this is in his samples, which we don't need anymore. We don't need his samples anymore, so we can get rid of those. Ow. Yeah, these are all samples. So we're just gonna ignore them. We're gonna get rid of them. Let's get rid of those the samples first. I sent an image on Discord. Ah, I think I see it. Give me a second. Give me a moment. There, we got rid of a bunch of stuff. TextMesh Pro is just it. Hey, we have 3 servers in common. No, we have 5 servers in common. Shit. Wait, you know Sympathy? Sorry. She's good people. Lampathy. The lamp. Let's see. That's TextMesh Pro. Can I do multiples at the same time? Oh, I can. Sweet. Okay, TextMesh Pro, all of these, ignore. This one. What? Still TextMesh Pro. Okay. Ignore. These are mine, if I'm not mistaken. Yeah, those are mine. This input system, I believe, is mine. Yeah. Woo-wee. That I'm going to leave. I'll leave that. These two need to be ignored. Yeah. Those ones don't even matter. This benchmark is TextMesh Pro. Yep. There is something that they need to do. And oh, I didn't even see the TMP for that one. I feel like this one's mine. Some of these are mine. We're going to leave those. This one I think is a TextMesh Pro. Oh, look, I was right. TextMesh Pro, I bet. I think that there should be an option just to not see certain folders. Just like ignore these folders. Don't even bother looking at them. Right? Yeah. Well, the thing is though that like they can be, they're not always in like the exact same spot. So like the ability just to add like an ignore anything in this folder would be amazing. Whew. This was TextMesh Pro. Ugh. This I don't think is mine. It's not. Sweet. We can ignore it. I think these are. Yeah, those I'm gonna leave. I don't want those to be ignored because I don't want to miss them if I need to come back to them for some reason. Same with these, because this sample Unity Physics 1.3.9, that I have the ability to change because we have the full source code for it. So if we decide that we want to change these for some reason, we can. Same with that. I think I've got everything, and that's pretty much it for things that we want to just actively ignore. Domain reloads. Do we even have any? No, not really. Huh? Yeah, got a couple. These are things that we can actually fix. Yeah. Summary. Ooh. Model behavior methods. There's 11 items that use this. These are TextMesh Pro, aren't they? Yeah. Ignore. Oh, are these the ones that are using the link then? Did it update the page for the link? I think it might have. But I do like this. Let's see if more details. Ah, here. Maybe? We'll come back to that. Project settings. Ooh, look at this. Look, we have things. Well, we'll definitely be coming back to all of this build size. I like this. This is really cool. Look at that. I really like that. This is a really cool thing. Okay. Yeah, I hope they do that as well. Package manager. Which one's my assets? This one. I wanted to add this. We're also going to set up Sentry at some point because I'd like to have Sentry. Do. Do you have any scripts that I can get rid of? Okay, no scripts. Good. Import. I don't want none of your scripts, bitch. You might be asking yourself why I'm importing a racetrack. And the answer is simple. I just really want a racetrack. No, it's just like uh if we take a look at a racetrack, yeah, tuning the feel. I feel like there might be a problem with the rendering here. What was it? It was yeah, the converter. It's under rendering pipeline converter. I guess we just do this. That was it. Ooh, there's a bunch that are still here. But we'll come back to that. And the important thing is that this worked. There we go. Look at that. Beauty. Now we create a subscene. Then we do this. We can get rid of this. Then we go to our prefabs. player vehicle. And then we just move this guy here out onto the track, and we should be able to drive. Look at that. I made a good prefab. Yeah, it did. Whee! I'm not sure why it feels like it slides. Like, I'm sure that it is sliding, but I'm not. I think it's because it's too sharp or not sharp enough. It's a weird feeling. You know what? I think adding engine brake is like all I need to make this feel better. Like a little bit of engine brake will be enough, I think. Cuz you never come to a complete stop. Like there's no way to come to a complete stop right now. You have to like reverse to come to a complete stop. Then I think when you reverse, you end up steering a little bit. Do you? No. Never mind. We. Anyways, I think engine brake will be enough to make this feel a little bit better. Or interesting. There's more of them now. There's a specific one here from a guy. He unfortunately uses AI voices, but this guy actually is really knowledgeable.
Compression ratio between.
Hey guys, welcome to this first episode of Unity Car Physics, and this is.
Hey guys, it's Axiomatic Uncertainty here, and today I'm going to be doing the first in a
0 and 1, enabling us to understand the spring's compression in a normalized.
Doesn't he? I think he's got like
Hello,
a.
everyone.
Yeah, here we go.
Hey everyone, welcome back to AshDev.
Yeah, this guy's puts out some interesting stuff here. I think he's got one recently where he was like flipping a car or something like that. He was doing something kind of cool. Yeah, no, it's just unfortunate because like it using an AI voice, like the way that he does it, unfortunately diminishes the quality of his videos in the presentation aspect audibly, right? But the rest of his video is really good and the content of his video is really good. But it makes it feel less credible when it's an AI voice, which is unfortunate because like he does good shit.
Today, we're starting a tutorial series on creating an arcade-style car controller in Unity. In this first part, we'll delve into the intricacies of suspension logic. Stick around till the end for some valuable insight.
Okay, so that's suspension. This is movement, follow, skid marks. Ownership episode. It's gonna be under movement. I'll be right back. Okay, I'm back. So I found out that I've been recording all of my stuff in 24 FPS, by the way. At 24 FPS. All of my devlog stuff, like all of the recordings that I've done for all of the Unity stuff, I think is 24 FPS. Yeah, but like it creates problems. Because you can't mix 24 and 30 very well. It's an awkward mix. Anime's at I think most anime like hand drawn animation and stuff like that is done all over the place. Uh I could 100% see that.
Hey everyone, you're watching AshDev. Welcome to episode 2 of our car controller tutorial series. Last time, we added the suspension system for our car. Now, we're going to step it up by adding some more features, like car acceleration and turning. Let's get started. First, let's switch up the car model. You can choose your own model. Just keep in mind that the car's Z-axis should be facing forward, and the wheels must be separate from the car's main mesh. Once you've got your model, remove the previous car body and replace it with the new one. Then, reposition the ray points following the same method shown in the earlier part. Now, open the car controller script, and first of all, we will add a ground check function to check if the car is grounded or not. For that, we will create an array of type integer called wheel is grounded. This will tell us how many wheels are on the ground. A value of 1 means it's on the ground, and the value of 0 means it's off the ground. Initialize it to an array of 4 integers, as we have 4 wheels. Next, create a bool called is grounded. This will store whether the
Uh, he might not have it.
car is on the ground or not, and initialize it to false. Now, some modifications need to be done in the suspension function. Change the for each loop to a for loop. As ray point doesn't exist anymore, it needs to be replaced with ith element of the ray points array. After that, we will set the ith element of wheel is grounded to 1 in the if statement where raycast hits the ground surface and else to 0. Now, for each ray point in ray points array, there's an integer in wheel is grounded array, which will be telling us if that ray point is hitting the ground or not. For example, if the first ray point is hitting the ground, then its related integer in the array will be 1, otherwise it will be 0. Now make a region named car status check, and in it, make a function ground check. Here, make an integer, temp grounded wheels, with initialized value at 0. Then create a for loop in which we'll add all the integers in the wheel is grounded array to temp grounded wheels. Then check if temp grounded wheels is greater than 1. In that case, set the bool is grounded to true, otherwise to false. Meaning if more than 1 wheels are on ground, then the car is on the ground. Now call this function in fixed update. Next, let's add some movement to the car. Create a header named input, and under it, add 2 float variables, move input and steer input. These variables will hold the player's inputs. Next, define a region called input handling. Within this region, create a function named get player input.
I don't know if he goes into this. I don't think he goes into it. Still good to know.
Speed set to 100. Then create a vector 3 current car local velocity. This will be storing the car's velocity in its local axis. Next, make another float. Pay close attention to the spelling of these commands to ensure everything works as expected, and then call this an update function. Now, create a header car settings. Create 3 floats acceleration set to 25, deceleration set to 10, and max speed set to 100. Then create a vector 3 current car local velocity. This will be storing the car's velocity in its local axis. Next, make another float car velocity ratio. This will be used to store how much speed the car has achieved regarding its maximum speed. Now, under car status check region, create a function, calculate car velocity. Inside it, set local car velocity to transform.inverse transform direction and pass rb.velocity. This will now return the car's velocity in its local axis. Next, set car velocity ratio as the magnitude of the local car velocity.
Oh, that's cool. Transform inverse transform direction. Oh. I wonder if that's something that I can do. Is that available in math? Vehicle input. Debug control system. Oh, suspension force job. Drive force job. This one? No, it was the Ragdoll launcher system. This one here. There it is. Math dot inverse. Or is it float 3? Inverse transform direction Hmm. In- Interesting. Okay. I guess this would be a float 3. We do that. 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 I don't know if that's correct. Transform dot. Okay, so if I've got the location, local to world. No, I want local transform, right? Ugh. Vehicle local transform. It does have it. It does have it. Transform dot transform. There it is, right there.
Divided by its maximum speed. This will now return a number between 0 and 1, where 0 is a non-moving car and 1 is a moving car at the maximum speed. Call this function in the fixed update function. Next, create a transform variable named acceleration point. Then create a region called movement. Under this, create a function named acceleration. In this function, we'll add force at a position to the rigid body with the value of acceleration multiplied by move input and then multiplied by transform.forward. The force position will be at the acceleration point and the force mode will be set to accelerate. Here's a quick breakdown of how this works. The force value is segmented into parts where acceleration determines the magnitude of the force, move input checks whether the user intends to move the car forward or backward, and transform.forward specifies the direction in which we want to apply the force, which is the forward direction of the car. And force mode is set to acceleration because we don't want the force to be dependent on the car's mass. Next, create a deceleration function. This would be exactly the same as the acceleration function, only the magnitude of the vector will be deceleration, and its direction on the opposite side of acceleration. Custom deceleration is used because otherwise, the car will be moving for a longer time. And to counter that, we could have increased drag, but drag is applied all the time and in all directions, so the car will start to fall slow, and also wouldn't move in the sideways direction. Now, make a function movement.
I felt that.
In it, check if the car is grounded, then call the accelerate and decelerate functions. Add this function in the fixed update. Now, in the editor, firstly, create an empty game object acceleration point and place this a bit below the car's center point, and then drag and drop this into references. If we play the game, it's working perfectly well. If you encounter any bugs or issues, feel free to join our Discord server to get help from fellow developers. Also, don't forget to subscribe. We notice many of you enjoy our videos but haven't subscribed yet. Your simple click really helps motivate us to create even more valuable content. Now, let's add the ability to turn. First, create a float named Steer Strength for controlling the turning intensity. Then create an animation curve called Turning Curve to adjust our turn strength based on the car's current speed. Now, inside the movement section, create a turn function. In this function, we're going to add torque to our car's rigid body. The torque amount is calculated by multiplying steer strength, steering input, the evaluated turning curve at our absolute current speed, and the math_f of car velocity ratio, all together with transform.up to ensure it turns correctly. We'll apply this torque using the acceleration force mode for making it independent of car's mass. Breaking down the torque calculation, steer strength determines how strongly the car turns. The higher the value, the sharper it turns. Steer input checks if the player intends to turn left or right, ranging from -1 to 1, where positive values turn the car right and negative values turn it left. The turning curve uses the absolute value of car's velocity ratio to adjust turn power dynamically. As the car's speed changes, the curve evaluates this speed to determine the turning power, and we use the absolute value because our curve only takes positive values. Then we have math_f to get the sign of the car velocity ratio to check if the car is moving forward or backwards so that we can invert the input accordingly. Lastly, transform.up sets the rotational axis, ensuring the torque is applied vertically, allowing the car to pivot correctly on its up axis, and the force mode is set to acceleration, making the torque application independent of the car's mass. This ensures consistent turning behavior regardless of the car's weight. Then integrate the turn function within the movement function inside the if statement. This is crucial because turning should only happen when the car is grounded. Back in the editor, adjust the steer strength to 15 in the inspector, and then tweak the turning curve.
Yeah, you noticed that too?
Feel free to craft a curve that suits your project, or you can replicate mine. However, you might notice the car continues to turn persistently. To counteract this, increase the angular drag to a higher value, like 10. This adjustment helps manage the car's continuous rotation, but also affects its turning power. Consequently, ramp up the steer strength to 30 to compensate. Both these values can be fine-tuned to match your preferences. After these adjustments, you'll see the car handles much better. To address the issue of the car sliding excessively, it's necessary to introduce some side force. This is because, at present, there's nothing countering the car's lateral movement. To tackle this, head over to the script and initiate a new float named drag coefficient. Then within the movement section, introduce a function named sideways drag. In this function, first define a float called current sideways speed to capture the car's current sideways velocity, which essentially is the x component of the car's velocity. Following that, create a float named drag force magnitude. This determines the amount of sideways force to apply, counteracting the car's sliding direction. It's negative because the force should act in opposition to the sliding direction. Adjusting the drag coefficient value allows for fine-tuning of this force, either increasing or decreasing its impact based on the needs. Next, create a vector 3 named drag force, which equals to the drag force magnitude multiplied by transform.right. This results in a vector 3 force ready to be applied. Proceed to apply this force to the rigid body at the car's world center of mass. Importantly, this force should act independently of the car's mass, so use force mode.acceleration for the application. Finally, ensure to call this sideways drag function within the movement function under the if statement, checking if the car is grounded. Head back to the editor and, in the inspector, set the drag coefficient to 1. Give it a play, and it's working great. That wraps up this part of the tutorial. In the next segment, we'll dive into adding visual elements to the car controller. See you in the next part.
There's this guy also has good content, but it's a little bit too advanced for what I want.
Offset and our velocity, but then we plug those in and we have our formula right there: offset times strength minus velocity times damping, and then that force is applied at the position of this particular tire. Okay, so as the car's driving along here, what we can do is we can zoom in on each individual tire. All right, so now we're down to the last force we need to calculate, which is in this blue direction, and it's comparatively simple, because all we really need to do is apply some force in the blue direction, and whichever direction the force is, the tires are going to slowly roll in that direction. So all I really need to work out is what kind of forces to apply to do things like accelerate and brake the car. A simple approach for acceleration would be when the player is pressing the accelerator, we just apply a constant force in the blue direction. Let's say 100. Go. 100, 100, 100, 100. Right. Constant force equals constant acceleration. And so the car is just going to kind of speed up forever. So we need something slightly more sophisticated. And in our game, we went with this simple animation curve that kind of represents the power or the torque of the car's virtual engine. And basically what you can see here is the amount of torque, or sort of forward force in this blue direction, is based on this lookup curve. And the curve is basically saying how fast is the car going right now. If the car's at a standstill, then we get 50% of our total power.
Yeah, I should probably do that. Yeah, give me 1 second here. We're gonna go to our dots vehicle. I'm gonna come into here, and I want this. This needs to start at 50 though. Oops. Wait, what? Oh. Yeah, no. Weird. Here we go. And let's hit play. Here we go. And then I'm going to edit this. I'm going to take the linear dampening. I want this to be 0.01. Want that to be nice and low. There we go. And then our angular dampening is what affects our steering. Well, I just got stuck. That's interesting. I didn't even know that that could happen. What just happened? I hit something so hard, my wheels got stuck. Okay. There's the linear dampening. Or sorry, angular dampening. We can say 0.1. Let's try that. I think this is going to allow us to turn really sharp comparatively. Yeah, for the most part. Steer force. Let's put this to 6.5. Yeah, that feels better. Whoa, what the fuck was that? What did I just hit? Oh wow, okay. So there's some collisions there. This road is very uneven, apparently. There's something over here. Weird, now I can't find it. Yeah, whatever. What the fuck is going on? Yeah, no, it's what? Okay, so these are the lines, right? These are the barriers, the trees, the walls, the lamps. The witch? Oh, okay, the seats. Sorry. The what? What is this? Oh, okay. Those blocks. That's fine. Bridges. The pit. Starlight? Oh, start light. Sorry. Ugh. Tents. Turn signals. Okay. Buildings. Interesting. I'm hitting something. But what am I hitting? I'm not seeing what I'm hitting. There's the oval. I think the oval is just one giant thing, right? You know what? I wonder if it's the lines or something. Okay, okay. Let's move the lines out. And anything that we don't care about colliding with, we'll move out. Bridges, we'll move these out too. Let's find out. So there's definitely something there. Now I'm stuck. What's going on? Let's turn on debug. Let's find out. There, I hit something. What the fuck did I hit? Move the buildings out. That's not what I wanted. Feels like there's something around here that I'm hitting. Like I'm colliding with something. But what? There it is. I think. Yeah. There. Right there. I think I'm clipping this. I'm clipping stuff like this. It's gotta be that. All right, let's bring this in. And we'll hit play and we'll drive around on just this track and see if it happens. Because I think we can stay on the actual track itself. We still hit something. I don't know what we hit. Oh, you know what? It might be the it might be the front. I think I know what it is. I think I know what we're hitting. Okay, let's go to here. We go like that, and we'll open this up. First things first. I want to do this. And then we need to move that back. This one? No. This one? No. Okay. This one. Then I think it's I think it's this. Oh, that's the wrong way there. There we go. I think that's hitting the ground, and it's what's causing the flip. The the front is hitting the ground as we go around these turns. That was weird. There's definitely some weirdness with the with this environment. What the fuck is going on here? It's just like it stops seeing the ground properly. I wonder if this is an in editor only issue. Let's test that theory and see if it's an in editor only thing, build and run. You need to set the scene. Oh yeah. I forgot. We'll do it after this. Mm. Mm. Boop, boop, ba-da-boom. Ugh. Mhm. Let's see how well it performs. There we go. Beautiful. There we go. And then we go edit, build profile. Add open scene. Now we do file, build and run. While this does this, I'm gonna go grab an ice cream sandwich. I'll be right back. Oh, hey, I'm Dwiven here. I still hit something. Now my tires are stuck. There's something wrong with this map. That's a bit upsetting. It's a mesh collider. And I'm assuming that the mesh collider isn't very good. What if we do that instead? Nope, that was not the right that was not the right answer. I do wish that Unity had more of the views that Unreal has. Anyway, so there are problems here. So that's fine. We just won't be able to use this track. Not the end of the world. Like, I was thinking this would be nice, but whatever. Did you hear that physics is going the way of the dinosaurs? I'm kind of upset about that. Mm. Unity is about to get fucked. I'll be right back. I think Unity's been moving away from it though. I know that Sound of roof work. Oh, okay. Interesting. So it sounds like they don't actually use it directly. Interesting. Weird. Okay. Does Valheim use his X? I have a friend I need to message real quick here. Sorry, Valheim is one of my friends. One of my friends is building a new PC, and Valheim is one of his favorite games. And Val is paying for the pro license, so it should be as easy as selecting Havoc in a dropdown. Yeah, no, but I don't know because Havoc is utilizing ECS, and my understanding is that the Valheim isn't actually using dots. So I don't know if they're I don't know if they're doing that. Because Unity.physics doesn't appear to be Unity.physics doesn't appear to be brain work good like sorry, Unity.physics doesn't appear to be using physics. Well, the default one is. So default, like a lot of games are about to get fucked. Unity games are about to get fucked really bad. When did Unreal move to Chaos? A while back, right? Yeah. Now, where was I here?
Power of our engine. And when the car is kind of going at like mid speed here, we have access to full torque. And then as we approach our top speed, how fast, so let's know access to the torque on some number, which is how strong is the engine, which is just the force value we've decided with just one curve. Okay, now that gets the car going, but what about stopping the car? Well, it turns out we've already solved this problem because stopping the car is the exact same thing as steering the car. Remember that the force in the red direction for steering was basically saying, hey, I don't want any velocity in this red direction. Tires don't like to slip. So let's calculate a force to remove velocity in that direction. Well, when the brakes are applied, we're doing the exact same thing. We want to basically remove any velocity in this rolling direction. And so we do the exact same math we do for steering, except in the blue direction this time to produce a braking force. And you can do other things with this, like you can put a maximum value on it and clamp it so that your brakes have some kind of maximum force they can apply to slowly bring the car to a stop. And you can also add things like rolling friction, which work very similarly, which is when you're not pressing the gas, we apply a light braking force in the opposite direction to slow the tires down to a stop. Here's a quick look at the acceleration code, and you can see basically we're just working out the car's speed, dividing it by the top speed of the car, using that to look up into our power curve, and then applying that force directly in the blue direction at the
Okay, let's get back to this. We'll go back to our scene. And we're going to just get rid of the cartoon pack altogether because it's not needed anymore. Weird. Okay. Let's take a look to see if we get any of that weird error. That feels like a really weird. I feel like I just saw some a graphics artifact. Maybe I'm crazy. Anyways, that's nice and smooth. Okay. So now we want to have this. This is the launcher. We're going to not worry too much about that. Ragdoll. We're just going to close all of these for the most part. There we go. And what we want is the control system. Driving force. So we get the tire transform forward. Drive force job. Here. That's the rotation. This is the drive force. Yeah, okay, this is calculating the drive force. Okay, so wheel transform. This is the chassis. This is the local forward. Get wheel forward. Um, get vehicle velocity. And that's going to be the chassis transform dot velocity. I need to get the velocity of the car's rigid body. Hmm. What's the chassis reference? Where are we getting the current velocity? Here's the speed. Wheel hit data. Velocity. Wheel hit data velocity. Oops, I was hitting the wrong button. There we go. Find usage. Oh, I have the physics world. Right? Do I have physics world? Where do I have physics world? It's the wheel of force job. Oh, this is the job itself. Let's do this for now. One second. Okay, this is where we actually apply the force. So what's going on here? Right, this is where we actually apply the force, right? Get rigid body. No. Here's our physics world, but this isn't applying the force. It's getting linear velocity. Wheel force job. This is the one where that I was thinking about here. Right. Spring velocity. Drive force job. What we want to do is get the get the linear velocity of the chassis. Oh yeah, I guess that's just speed, right? I feel like this is more complicated than it needs to be because all we really yeah, all we really care about is the forward for the wheel, right? It doesn't change. And speed would be we don't worry we don't worry about this for doo-doo-doo. Hmm. What's temp drive amount? Um, hmm. Give me a second. I'm just thinking here. Where are we getting drive amount from? This is from wheel drive control? Wheel drive control. Is wheel drive control up here? Wheel force job. I'm going to try something. I don't know if this is going to run at all. Because if this is the case, I don't know that, like, this, I don't think this needs like 3 different steps to do this. I think we can simplify this. Yeah, we can effectively get rid of the other one, right? So we're revamping all of this. So it looks like you will need a mono behavior at some point, even if you try to use 100% ECS, or it's just may lack of knowledge at the moment. You well, you can't not have mono behaviors because you need them for the authoring at the very least. But it depends on what you mean by you'll need mono behaviors. You'll need a mono behavior, right? Like it depends on what you mean. Yeah, so like any interaction with any input system will require a mono behavior with that shims communication because that doesn't exist. I'll be right back. In the meantime, though, I should probably just like dump some. Just did an ad. I'll be right back. Oh, I forgot to do my Japanese homework this morning. Oops. Hi is back. Oh wait, actually. Oh, sorry, BattleNet. One of my friends asked me to watch something. Give me 1 sec. I want to see this. Ooh.
The tavern's always open.
Mm-hmm. Yeah, there we go. He said I'll be proud of this game. What the What a great game. That thing's fucking huge. I wonder if he's just waiting for something to be able to eat it. The cheese. My friend is really good at economy builds. What this turn 10. Yeah, he's wrecking people's face. You only played for a couple of years when the game first came out. It's a very different game now. Battlegrounds is very different. What's the thing here? At the start of each turn, get a random minion of your choice, of your most common type. Oh, no wonder he's fucking rolling people. Oof. He ties. Oof, he's not big enough yet. This is just pure demon, right? Yeah. Yeah. No, Battlegrounds is an interesting game mode, to say the least. I think it's classified as an auto battler. like auto chess. I'll be right back. I need water. Yeah. So what happens in this game mode, I don't know, is you have a buy stage where so right here he's not playing, he's just watching, right? And paying attention to like what everybody has. And in this state, the recruit stage, he can buy from the tavern for gold that he has down here. So he's got 14 gold to buy. Each minion in here is 3 gold, and this is 2 gold. Yeah, then might be different the next one, right? Buffs that happen here. So like when he sells this, it's going to add attack. When he this one will give 17 health to his minions when he sells it. 18 health, right? No. There's no card packs. You don't build decks. You build a board. Everybody has access to the same cards. So right now there's demons, dragons, elementals, mechs, and undeads. And then he's playing this minion, this champion. Passive, when you play a minion, give it a 1/1 hat that passes to a friendly minion when sold. Right? So he has 13 gold. Buying a minion is 3 gold. Selling a minion gives you 1 gold back. Tavern spells, like this, have a cost to them that's in the top left corner. This one costs 3 blood. So it gives you 3 damage if you buy this. But it gives you 1 gold. So if you really need the gold and you can sacrifice the blood, you do it. So here you just saw him do a play. That was his turn. He played. Now he's entering combat. So he effectively hands off keyboard for this. Right? This is all automated at this point. He doesn't choose. The only thing he chooses is the order that his minions attack in, because his minions attack from left to right. Right? Same with the enemy. They attack from left to right. But you don't know what your minions are going to attack, with the exception of they will always attack taunt first, right? So if there's 2 minions with taunt, it will attack one of the 2 minions with taunt. Right? So this is always going to be the first of his minions that's attacked. Doesn't matter. Always that one. So it's a pretty easy game mode, right? And then everybody has like their own little things. So this one, passive, give 1/2 and taunt 2 minions summoned during combat, right? Or this guy, choose 2 minions, they gain each other's attacks until next turn. Okay. Then there's buffs. Any buffs that happen in the buy phase are permanent buffs to those cards, unless otherwise explicitly stated. And then anything that happens during combat is a temporary buff, or it's usually temporary unless also explicitly stated. So it will say like permanent. Then if that's the case, then it's a permanent buff, regardless of where it happens. It just matters that it happened, right? So right now he's every time he buys and sells, he gives 1/1 to one of his minions because of his hero power, right? This has seasons, and every season they release a battle pass, and the battle pass allows you to pick between 4 heroes at the beginning, 4 champions at the beginning, and if you don't have the battle pass, then you only get to pick between 2. That's where they make the money from this game mode. He makes it into the last 2, guaranteed at this point. Oof, ooh, ooh, health baller. So there, he passed the hat. You can see him buying and selling. You'll see him do a lot of buys and sells. There we go. So right now he's going to go against a dead player this turn. So the player that he's going against will have no upgrade. Will not be upgrading. So they're not in the lobby anymore. They died. As long as you make it into the top 4 in singles, you move up. And if you make it, if you don't, you move down in rank. Huh. And I think 6K is open. Anything after 6K, you're in opens. Ranking or something like that. I don't remember. I don't care that much. We play duos a lot. Duos is where you both get to play together. And you can pass cards back and forth and stuff like that. We've done some pretty disgusting things with that. So I think it was last season. We got a minion that had like 4,000 health and like 30,000 attack. Oh no, it was like 40,000 health and like 4K attack damage. It literally the amount that the numbers actually break. They break. They bleed into the card next to it. It was fucking stupid. Like just the dumbest thing that you've ever seen. So they had this card called I think it was CMOS or something like that. And it was an elemental. And when you play it, every time you play it, right? When you play the card, you get to decide, do you want to double its health or double its attack? And what we did was we passed it back and forth after playing it because it gets to keep its stats. So we played it, double its health, right? Buff, and then we would pass it, and then play it and double the health, and then pass it back, play it, double the health, pass it back, play it, double the health, pass it back, play it, and so it's an exponential game. And it is absolutely stupid, but hilarious at the same time. It's hard to say who's going to win this because this other guy here has permanent permanent shields. And the shields could screw my friend here. Although it looks like he's about to get destroyed because of he's not as big. I think he's gonna buy the. Yeah, this is guaranteed to be a. Oh, it's a crasher. It's too late. There, he took the health. He's just like, I'll take the health for the one gold. Sheer greed, sheer greed. Oof, that hurts. Yeah, this is kind of a back and forth here. If anybody's capable of making this work, it's it's him. Oh, oh, that's a good little card there. Personally, I think he needs to move the fire guy down one because he keeps getting fucked by the the shields. But he's a better player than me, so I concede to his knowledge. I think he might win this one just because he got no, damn, he didn't get this one. The shields, man, it's the shields. The shields are too strong. wonder if he buys the gold. Yeah, I had a feeling he wasn't going to. It's too late. I had a feeling he was going to buy that. That gives him two taunt buffs. Oh, interesting. Wasn't sure if he was going to use it, how he was going to use that. But this here could be last round. Just because of the divine shields. After you play an elemental, give a friendly elemental other than it 2/1. Oof. Oh. Oh. Die. Fuck yeah. What we like to see. Knew he was gonna buy that. Oh. He can't buy the gold. He can't buy the health and that gold because it would literally kill him. Yeah. No, he's cockroaching this one. He might be able to turn this around. Actually, I shouldn't say might. I think he's starting to turn it around. I guess we'll have to it will depend on how lucky this other guy gets. I have a feeling he's going to drop some of his non shielded guys. I'm a little bit surprised. I figured he would drop at least one or two of them. That's round. Yeah. Yeah. Anyways, that's my buddy. That's my buddy Patches. He's good at video games, unlike me. I'm not actually very good at video games. Like actually not very good at video games at all. I think we can actually just get rid of this altogether. Find usage. I think we can just go like this. I'm gonna do this and see if we can still drive. I have a feeling the answer is new, but I don't think this is going to drive anymore. Yeah, it doesn't drive. Because we don't have anything giving us the force. But we have everything now in the wheel force job. So we can just do it here, right? Get the forward direction of the chassis. This is CX index. So we need to get the rigid body. Get the rigid body of the... No. Get the forward direction of the chassis. Actually, do we need it? Get angular velocity. Get linear velocity. Then we give it the physics index. Rigid body index, CEIDX. And this gives us the linear velocity of, which is a float 3, chassis. Where is my video? Here we go. Okay, so to get the what we want here, we need the wait, no, that's the tire transform. The chassis linear velocity. Yeah. Okay, so if wheel drive controls dot drive amount. I want to change that. I don't like drive amount. Amount is greater than 0.0f is the vector. So this would be math dot of the car transform. Okay, so here we'll say this is 2. We need the we need Can I get the no, because it's just a float 3, right? There's a rotation. Center of mass. Hmm. I think this is a get forward direction from linear velocity and rotation. Find forward direction based on linear velocity and rotation. To find the forward direction based on the linear velocity, use the right hand rule. Put your thumb in the direction of the angular velocity, and your finger will naturally curl in the direction of the linear velocity. Math equation. How fast is an object rotating? We defined angular velocity as the rate of change of an angle. We could ask for, oh no, we have the local transform. Oh, wait, we have the local transform. We can get it from here. gas amount, and then we do the dot on the linear velocity. And then the car transform, which is going to be the chassis transform dot forward. Forward speed of the car in the direction of driving. Normalized car speed. There's the clamp. What we want is we want math.abs, and then we take car speed divided by car top speed, right? We'll say 10,000 for now, right? Or yeah, 10,000 for now. And this would be a float. Normalized speed. Right? And then we need a math.clamp. It's supposed to give us a float, right? So yeah, no, this would give us a float. So we can just do this. Oh, actually, we can figure out drive torque based off of this. Do this torque. Here. What was temp drive amount? There it is. Oh, this is completely gone. Oh no, this is, yeah, here we go. Is literally okay. Yeah. Gas amount. Mm. Car top speed. What do we want the top speed to be? We'll use max drive torque. Yeah, this would be max drive torque. There. Then we do available torque. Normalized speed, yeah. Times wheel drive controls dot gas amount. And then local forward. We apply the physics here, utilizing this. Well, I don't think that we care too much about the local forward, to be honest. Just do this. And then this would be, let's see, accelerate direction. Our impulse is, sorry, acceleration direction. Impulse here would be the available torque times, sorry, this would be the wheel direction, right? Wheel transform dot forward times that about sums that up. Now we should be able to drive now. Let's see if it works. Hell yeah, it works.
Location for each tire. And there we have it. We have a fully driving car with suspension and steering and acceleration and braking. And we can really tune the driving car directly in the blue. Clamp it so that your brakes have some kind of maximum force of our total. And so the horizontal axis here is just how fast. Torque again is just a multiplier on some number of M's or realistic car that behaved in a way we could easily tune and control with just one curve. A force to remove velocity in that direction. Well, when the brakes are applied, we're doing the exact same thing. We want to basically remove any velocity in this rolling direction. And so we do the exact same math we do for steering, except in the blue direction this time to produce a braking force. And you can do other things with this, like you can put a maximum value on it and clamp it so that your brakes have some kind of maximum force they can apply to slowly bring the car to a stop. And you can also add things like rolling friction, which work very similarly, which is when you're not pressing the gas.
Okay, so you will notice that we do have some speed when we do this, but it's very light. Because we're not doing the more complex math to give it a proper acceleration like we were before. So I'm going to come down here and we're going to find that. Here we go. We can get rid of that. We don't need this. Wheel.drive torque. Speed / wheel drive torque. Okay. But speed is we got speed there, car speed, yeah. Okay, those are done. Temp drive amount, that's the gas amount. Get rid of this brake, we don't need that right now. Torque is evaluated. Here's the okay. Available torque. Wheel drive curve times temp drive amount, which is gas amount, times wheel dot max drive torque. Here we go. Let's see how this feels. Oh, yeah. Let me remove her. There we go. Look at that. The next thing that we need to do is figure out the steering.
Okay, so as the car's driving along here, what we can do is we can zoom in on each individual tire and get the velocity of that individual tire, which is just the velocity of that point on the car's rigid body. And then we can break this up into our blue and our red directions. So the blue direction, of course, is the direction the tire likes to roll, and the red direction is the direction the tire doesn't like to slide. And so we can take the current velocity for each tire, which in this case is this orange arrow, and we can use a dot product to break it up into two separate components. The component that's going in the rolling direction, the blue direction, and the component that is in the sliding direction. And now we're going to currently focus our attention on the red direction because that's the force we're calculating right now that's going to produce steering. So if we just think about this, this is the current velocity of the tire in the direction of the red line, the direction we don't want to be sliding. And so we're going to need to calculate some sort of force that says don't slide in this red direction, right? Ultimately, we don't really want any velocity in the red direction because that velocity means the tire is slipping sideways. So we're going to need to calculate some kind of force for this. And force, of course, is mass times acceleration. So if we want a force, we can think about it in terms of an acceleration. And an acceleration is just a change in velocity. So what we can do is ask ourselves, what change in velocity would we like to occur? Well, actually, that's pretty straightforward because we currently have this gray line. That is the current velocity in the direction of the red sliding direction. And we don't want any of that velocity to exist. We don't want to slide sideways. So really what we want is a change in velocity that is the opposite. We want to remove all of this velocity. So if we just take that current velocity and flip its direction, that's the change we would like to have occur. And at this moment, when we flip it, we could also, for example, scale it down a little bit and say, well, we're okay with the tire sliding a little bit. So maybe we're only going to try and remove 50% of the velocity. Or the car should be sliding a lot right now. We're on ice, so let's only remove maybe 10% of the velocity. But basically what we're going to do is we're going to take the current velocity of the tire in the sliding direction, and we're going to flip it around. And that then is a change in velocity that we want to have happen. So we take that vector, we divide it by some amount of time, a small amount of time, to say this is the acceleration we want. We want a change in velocity over time. And then that value becomes our force. So here you can see if we just take the velocity in the red direction and we completely negate it and use that as our force. Here's a car example with 100% grip. And you can see the tires do not like to slide. And of course, they're so grippy that maybe the car will flip over depending on things like the center of mass. Now here's an example where we're only canceling out 5% of the slip velocity. And now you can see we've got real slidey car. This is a front wheel drive car.
Oh, you know what? If I actually go to my truck, right? No, grip factor is 1. This I think needs to be 0.95. Put this at 0.95. Let's see how this does this slide? Yeah, it still slides like crazy. Even the front tires are sliding though. I think we just have a bad a bad amount of I think we have got a bad algorithm for steering. Oh, we do. We absolutely do. Yeah, okay. Ice Road Trucker. Yeah, well, just convert the logic, right? I think I a little bit understand why. Like why this is being broken out into 3 different pieces to some degree, but it's a bit much. Well, not 3 different, I think it's 4 different pieces or something like that. It's just a little bit too much. This is bad. Like this math here is not what we're looking for. Doesn't appear to be tunable. But if effectively we're rewriting all of the vehicle control system. With that though, I think I might actually call it a day. I'm running out of steam here. Still being sick sucks. I did get 4 hours into a stream though today, and I'm pretty happy about that. So tomorrow I'm gonna be late because I have an interview. So I have an interview at 10:30, so I'm gonna be a bit late tomorrow, more than a little bit late tomorrow. I'll probably be on at around 11 or 11:30 tomorrow. Yeah. So that's gonna happen tomorrow. And anyways, thank you to everybody who showed up, and hopefully tomorrow I'll be able to go a bit longer. I'm starting to get a lot of my strength back. I'm feeling better, so yeah. Anyways, we will rip apart all of this game logic tomorrow and see if we can't get it to work exactly the way we want it to. Ta-ta for now.